friends, in today's video we are going to solve a question based upon the concept of second order derivative test. But before we go into the example, let us recall what exactly is this second order derivative test. So second order derivative test is given by these three steps. So first of all, what we have to do is this: find f prime of x and f double prime of x for the given function f of x. Then the second step, we have to take f prime of x is equal to 0 and solve for x. Suppose the critical points are a, b and c, which will be the values of this x when we solve this for x. Let us take x is equal to a. So this is what we are supposed to do. We have to find the value of f double prime of a. Now if the value of f double prime of a is less than 0, then x is equal to a is a point of local maxima. Or if f double prime of a is greater than 0, then x is equal to a is a point of local minima. And if f double prime of a is equal to 0, then the test fails. So what are we supposed to do? Then we have to go back to the first derivative test, where we were finding if this point A is a point of local maxima, local minima, or a point of inflection. So now let us take a look at a real life example and try to see how can we solve it using this concept of second order derivative test. So here, let us look at this example. A rectangular thin PVC sheet of 30 cm by 14 cm is to be made into a box without top by cutting off square from each corner and folding up the flaps. What should be the side of the square to be cut off so that the volume of the box is maximum? Also, find the maximum volume of the box. So here, a rectangular sheet of 30 cm by 14 cm is given to us, right? Then what is given to us? We have to cut off squares from each corner, which are all of these 4 squares, correct? They should have the same dimensions. So now we have to find out that what should be the side of this each square so that when we fold this up, the volume of this box will be maximum, right? That is what we have to find out. So first of all, let us suppose that we are cutting off the squares and then we are folding up the flaps to form a cuboid without the top. Okay, something like that. So here let x be the length of the side of the removed square. Then the length of the open box L will be what? Now remember, this is the length, right? That is 30. Now from this 30, we are removing this much length and this much of length, correct? And the measurement of side of each square, it is what? X, right? That is what we have supposed here, correct? So that means we are removing x and another x from this 30. So this will be what? 30 minus 2x, correct? Same way, what will be the breadth of the box? Now breadth of this sheet, it is given to us 14. Now again here we will be subtracting this x and this x from total of 14. So here it will be 14 minus 2x, correct? And what will be the height of the box? Remember this, when you fold it up, then that will become the height, right? So that will be nothing else but x. So now we want to find the maximum volume of the box, correct? So let us suppose that V be the volume of the open box. Now how do we calculate the volume? By multiplying length, breadth and height, right? So this is length, this is breadth and this is height. If you multiply all of these values, then this will become 4x cube. This will be minus 88x square, and the last one, it will be 30 times 14, that will be 420x. So now we have to differentiate this with respect to x. That means we have to find what is v prime of x. So now this will be what? The derivative of 4x cube is what? 12x squared. So here it will be 12. Now The derivative of a minus 88x squared, it will be what? Minus 176. Why? Because the derivative of x square is what? It is 2x. So 2 multiplied by minus 88, we will get minus 176. And this will be nothing else but just 420. So now we have to find the critical points. To find critical points, we have to equate this equal to 0. So after equating this is equal to 0, what will be the values of x? Remember, this is a quadratic equation, right? So solution of quadratic equation, we will have two roots. They can be equal also. So let us find out the values of this quadratic equation. So now this is a quadratic equation which we want to simplify. So we can take out 4 as a common factor from the left hand side. So we will be left with this 3x squared minus 44x plus 105 is equal to 0. Here to find the roots, we can factorize this out as 3x squared minus 9x minus 35x plus 105 is equal to 0. So if we find the factors, then this can be written as 3x minus 35 can be taken out common from these two. So what we will be left with is x minus 3. So from here, if we find the value of x, it will be something 35 upon 3, right? Or x will be equal to 3. So that means the value of x, it will be equal to 11.66 something, or x will be equal to 3. So let us substitute those values here. But when x is equal to 11.67, if we substitute the value of x in this length and breadth, then we will see that the value of breadth will come out to be negative, right? And remember, length, breadth and height, they are measurements. So they cannot be negative. So that means the value of x is equal to 11.67 is not correct. So that means x is equal to 3 centimeters is possible. So now let us substitute this value of x is equal to 3 to find the second derivative of v of x. So now what will be the second derivative of v at x, or we can say v double prime of x? That will be what? From here we can find it out. It will be 12 times, it will be 2x. So it will be 24x. This will be just minus 176. Now what we have to do? We got the critical point, correct? Now we have to find out if we will get the maximum value or minimum value at this critical point. So what we have to do? We have to substitute this value of x in this second derivative, right? And if the value of the second derivative is coming to be less than 0, that means we will have local maxima at x is equal to 3. And if this value comes to be greater than 0, that means we will have local minima. Let us check that. So substituting value of x is equal to 3 here, we get it to be minus 104. That is less than 0. That means by second derivative test, we can say that x is equal to 3 is the point of local maxima of v of x. That means we found the value of x, which here it is equal to 3, which when we subtract the squares, we will get the maximum volume of the box. So now let us find out the value of the maximum volume of the box. So for that, let us substitute the value of x is equal to 3 in this equation of volume, that is v of x. So here we just have to substitute the value of x to be 3, and the total, when we simplify this out, it will come to 576. So that means the side of the square to be cut off should be 3 centimeter long to get the maximum volume 576 centimeter cube of the box. So this is how we can apply second order derivative test to maximize volume. I hope you were able to understand this question. Thank you so much.